So now let us look at a very interesting unit of measurement of angle, which is a radian. So to understand the radian, let us look at some background. So in physics, scientists have observed that there is a relation between the linear quantities and angular quantities. So if you go to this chapter of circular motion or rotational mechanics, you'll see that all the angular quantities will be related to linear quantities by certain formulas. For example, the linear velocity of a particle can be written as radius times the angular velocity. And the acceleration, the linear acceleration of a particle is given by radius times the angular acceleration. So on, you have certain formulas relating the angular quantities with linear quantities. And once they observed these formulas, so they got interested in certain things called dimensional analysis. So they have done the dimensional analysis for this formula. So by now you would have known what dimensional analysis in physics, because that's the first chapter in physics that you have in 11th class. So once you do the dimensional analysis for this, what is the dimension of velocity? Velocity is nothing but length upon time, right? So length upon time is equal to, what is the dimension of radius? Radius is a length. So length times angular velocity is nothing but angle rotated by time. Angle rotated in a given time, per unit time. So the dimension of omega should be angle divided by time. So once you analyze this length and this length is getting cancelled, this time and this time is getting cancelled. So theta is turning out to be a dimensionless quantity. The angle is turning out to be a dimensionless quantity. So similarly, if you go for this, acceleration is length upon time square is equal to radius is length and angular acceleration is theta by time square. This t square and t square is getting cancelled, L and L is getting cancelled. Again, theta is turning out to be a dimensionless quantity. That means whenever you need to substitute theta in problems, you should be able to use a number without units. So theta has to be a number without units. So that's what is turning out to be the conclusion from this analysis. But whatever we have studied till now, angle has units, right? So in degree measure, one complete rotation is denoted by 360 degrees. 360 degrees. But if I ask you why 360, there's no logic about that. Because someone have started measuring angle, they would have liked the number 60 very well. So that's why one rotation is divided into 360 degrees and 1 degree is divided into 60 minutes and 1 minute is divided into 60 seconds. There's no logic for this number 60 or 360 or whatever, 90 degrees, so on. So even in centesimal system, why should a right angle be divided into 100 divisions? There's no logic about that. I can as well divide them into 120 parts, 180 parts, or 200 parts, or 500 parts. So the more parts I divide, the same angle will be represented by different numbers. So if I go on substituting numbers without taking care of units, I'll get different answers each time. So 3 degree measure and grade measure has not been accepted as the SI units for measurement of angle. And scientists and mathematicians as well have started to look for some way of measurement of angle where you don't need any units to express the number. So radian is a unit of measurement of angle which is not a unit also. So radian is a unit of measurement of angle without the use of any units. So radian measure gives you the angle as just a number without using any units. So let us see what this logic about radian is. Many students feel a lot of difficulty in understanding radian. So let us try to simplify and understand the meaning of radian. So to understand a radian, so let us first consider a circle with radius r and center O. So let us take a circle with radius is equal to r and center is equal to O. Now let us join the center with some point A on the circle. So we know that the radius is r. Now what you do is, assume that you are the person who is walking on the road. So whatever is the distance r, you just go through the distance along the curved circle. So let us say that this r is equal to the length of the arc r. So let us say that the length of arc is also equal to r. So as we move here, let us say that I have reached the point B. If I move along the circle through a distance of r, let us say that I have gone from A to B. Now let us join this B with this O. So if I consider this as the initial ray and this as the final ray, whatever is this angle, this is called 1 radian. So 1 radian is the angle subtended at the center by an arc of length exactly equal to the radius of the circle. So that's the definition of radian. So radian is angle subtended at the center by an arc of length exactly equal to the radius of the circle. So equal to the radius of circle. So this is the definition of a radian. So you can take any circle, you can take a small circle or a big circle. So in both the circles, if you apply the definition correctly, you get the same angle, because this is a big circle, has a big radius. This is a small circle, assume that. So it has a small radius, let the radius be capital R. So you have to move along this curve only through a distance of r. Now if you join these two, so this angle is 1 radian. So as you can see, by similarity of circles, this angle will be exactly same as this angle. If the radius is more, the length of arc is more. If the radius is small, the length of arc is small. So by symmetry or by similarity, so the measure of 1 radian does not depend on the size of the circle. So even in a small circle or in a big circle, if you exactly follow this definition of radian, you get some angle which is taken as 1 unit, which is called 1 radian. And 1 radian is represented by a superscript c. 1 radian is represented by superscript c. So now let us try to understand this radian unit further. So now let us assume that the radius of the circle is 1. We have already seen that the measure of radian does not depend on the radius of the circle. So for example, let us take r is equal to 1. So now I assume that I am walking on this circle. So I am going on walking. So my question is, as I go on walking from this point, if I complete one rotation, what is the length of arc that I have covered? So length of arc for one complete rotation, is nothing but the circumference of the circle, right? And what is the formula for circumference of the circle? 2 pi r. This 2 into pi into r is 1, that is equal to 2 pi. So that's the length of the complete arc. So 2 pi, if you calculate, it will be something like 2 into approximately 3.14, it is approximately 6.28, so on. You have a lot of numbers after it, because pi is an irrational number. You have a lot of numbers after this. So approximately, if I complete one complete rotation, so I cover something like 6.28 units of length. So if this is 1 centimeter, I'll cover 6.28 centimeters. If this is 1 meter, I'll cover 6.28 meters. So let us say this is 1 meter, for example. So now as I come from here to here, I have totally covered a length of 6.28 something meters. So now let us see how many radians I have covered. So let this be called the zero distance. So, and after completion of one complete revolution, my length traveled is 6.28 something meters. So now from 0 to 6.28, I'll cover 1 meter, 2 meters, 3 meters, so on. So let us say that this is the point where I have completed exactly 1 meter distance. Let this be the point where I have covered exactly 2 meters distance. So let this be the point where I have exactly covered 3 meters of distance, 4 meters, 5 meters, 6 meters, and this is 0.28 meters, whatever it is. Now, as you can very clearly see, if I cover 1 meter is exactly equal to the radius of the circle. So this angle has to be 1 radian, right? And from 1 meter to 2 meters, again this length of the arc is 1 meter. This is also equal to the radius of the circle. So the angle subtended will be 1 radian here also. Similarly, this is also 1 meter. So the angle subtended here should also be equal to 1 radian. Here also it should be 1 radian. Here also it should be 1 radian. Here also it should be 1 radian. So from here to here I have covered 1, 2, 3, 4, 5, 6 radians. And you have a small part left here. So if the distance is 1 meter, I cover 1 radian. If the distance is half meter, obviously I'll cover half radian. If the distance is 0.25 meters, I'll cover obviously 1/4 radian, so on. So correspond to 1 meter, I cover 1 radian. So correspond to 0.28. This is 0.28 something, 0.28 meters. I cover how many radians? 0.28 radians, right? So this small angle is approximately equal to 0.28, not exactly, so on, radians. So one complete rotation is approximately equal to how many radians? So one rotation, complete rotation is approximately equal to 6.28 so on radians. And this can be written as, how did you get the 6.28? This is nothing but 2 pi. So I say that one complete rotation is exactly equal to 2 pi radians. One complete rotation is equal to 2 pi radians. So half rotation is exactly equal to half of 2 pi radians, that is pi radians, right? Half of this. And 1/4 of rotation, that is one right angle is exactly equal to half of this half rotation, that is pi by 2 radians. So the conversion between degrees and radians will not be a nice rational number because pi is an irrational number. So one right angle is equal to pi by 2 radians. So this is the understanding of the radian system. Now let us understand how to interconvert between degrees, grades and radians. Cut कर लीजिए.